right, so once we simplify our function by multiplying by x both sides, or top and bottom, we're going to use our quotient rule. Derivative of the top is 3. Multiplied by the bottom is an x squared plus 5x minus the top times the derivative of the bottom all over, oops, I did not do the derivative of the bottom, 2x plus 5 all over the bottom squared. Now, if I was asking you to find that derivative, and that's your final answer, then I would have to simplify the top. Okay? Yes, square. I would not FOIL out the bottom. I would just simplify the top. That's going to give me 3x squared plus 15x. What do you do over here? So you can distribute the negative to one parentheses and then FOIL, or you can also FOIL and then distribute the negative at the end. Either way works, which would probably be what I do, but either way works. Because I'm not doing anything to the bottom, I'm just going to skip writing that right now for the sake of space. That's going to give me negative 3x squared when I combine this with this. 15x minus 15x will cancel. That minus negative 2x will give me plus 2x plus 5 over the bottom squared. All right, so that's my derivative. Now, let's review the directions that come after this. We did this in 7.2, but we're coming back. When it says find the equation of the tangent line, we had 3 different sets of directions we talked about. Find the slope of the tangent line, find the equation of the tangent line, and find when it has a horizontal tangent line. Those are like the 3 basics we need to know. If it asks me to find the equation of the tangent line, what 2 things do I need to do?
Y minus 1.
I'm going to have to do y minus y1 equals m times x minus x1. What else do I have to find first? Slope. How do I find slope? Okay, derivative at my x value. Okay, so that means, yes, that's ugly. What do you also have? A calculator. Please use it. Okay, so this is where you're plugging in -1 for all of your x's. But this, even if it's not super nice, and especially if I didn't ask you to find the derivative first, did you even need to clean it up? You could have just plugged in -1 before you did any of the cleanup to get the slope. I mean, it might not be super fun to do, but you have a calculator. You plug -1 into the derivative. So I'm going to plug in -1 to my derivative. What's this going to give me?
Your slope.
My slope. So I'm going to do -3 times -1 squared plus 2 times -1 plus 5. That gives me 0, which actually makes me stop. Why does that make me stop right there? If 0 is on top, what's my slope? 0. If 0 is on top, no matter what number is on bottom, it's going to be 0. Unless for some reason it's 0 over 0, which it really shouldn't be. But
what would it be if it was undefined?
That would be undefined. That would be a vertical line. But a vertical tangent is almost impossible. So, how do you then find the equation of the tangent line?
Now you use the points and do y minus y1.
Now I do. Y minus y1 equals 0 times x minus x1. What does that 0 do to the second half of the equation?
All 0.
It's all 0. So what's my answer?
Y equals 1.
Y equals 1. Okay? So that's the same directions that we did in 7.2. It's just we used quotient rule with it. Okay? That's quite a bit of work for a question. I will be super honest with that. It is a little bit satisfying, yes.
Because it goes all the way down.
I know. And it simplifies real nicely. What formula do I need to use for example 3? quotient rule, right? Now, quotient rule is going to require me to do something with cosecant of x. We haven't done a whole lot with cosecant. Yes.
Can we use like on one of these, like the y minus like, can we, you know those old rules that we had with that big sheet, like you could.
The trig derivatives?
The trig derivatives.
You can, yeah, on some of them.
Also,
We
can
will,
Was
at
that
some
a
point.
life hack?
Huh?
Can you use the quadratic formula?
Can you use the quadratic formula if you want to?
Okay.
Is that a life hack?
What? Yes. It's coming back. The trig formulas are coming back at you.
Those quadratic.
I may come back to example 3 and 4 if that's okay with y'all.
I'm okay.
I'm thinking maybe splitting today may be useful to us. So let's flip over to example 5. Someone asked about this in a previous class, like once you find the derivative, can you find the derivative again and again and again? Yes, yes you can. There are multiple derivatives. They're not any scarier than original derivatives. So like if I asked you to find the derivative of this f of x in example 5, y'all know how to do this, right? Find the derivative of each term separately. Is this anything different than the basics that'll be on our quiz? No. So take a minute, find the derivative. So once you kind of get down with these, with the x's, the exponents eventually go all to 0. You end up with just those, the derivative being 0. Let's do this last one. Sine of x, and it wants us to find the 7th derivative. Okay? So let's just start there. Let's start with finding the first. Right now there's no shortcut to finding the 7th, but let's just see. First derivative. What's the derivative of sine? Cosine. Second derivative. Negative sine.
So would that be just cosine?
Third derivative is going to be cosine is the derivative of sine, but it's a negative sign, so what is it? Negative cosine. And then it goes back to positive sine on the 4th. Right? And then, obviously, right, we're back to the original.
So we're at 4.
So then it just repeats, right?
Negative cosine x at 7, right?
So if I was to just write it, I now know the derivative of sine is going to be cosine. The derivative of cosine is going to be negative sine. The derivative of negative sine is negative cosine. And it continues in the cycle, right? So it might sound ridiculous that I say, what is the 42nd derivative?
It's like the imaginary numbers.
But, yeah, it is kind of like the imaginary number thing in Algebra 2 where they say if you see the pattern in the I cubed and the I to the 4th and all of that, okay?
Oh, this is like the eyes. Yeah. I remember that.
Yeah, so you could, if you just recognize that the derivatives go in sets of 4, you're essentially just saying, where does 42 fall in the set of 4? Like, I wouldn't even follow this down and do every derivative.
Oh, let's do 41 derivative.
Like, I would just know 8, and then I would kind of think through 9, 10, 11, 12, 13, 14, 15, 16, and so on.
Can you just do like 40 times 10? So you know that the 40th is going to read.
So you know the 40th, it's going to be like 10 sets out. So then 42 is going to fall like the second one down on one of the rows. So it'll be negative sign. Yeah.
Oh, wait, can't you just divide it by 4?
Mm-hmm. So 42 itself doesn't divide evenly by 4. It divides in 10 times with 2 left over, which means you would be like 2 down on your list. Yeah. So then your 42nd derivative
Long division? Oh.
would be negative sign.
Oh, let's bring long division back.
If you didn't feel like doing the division thing, you could just count out to where 42 would fall in that pattern, and that would be pretty quick too.
So this is
Okay.
one of them that you can't use the quadratic formula for, right?
Oh, no.
Yeah.
All right. So let's break our homework down for this.